Hello, my name is Torsten Hoefler and my lab is working on next-generation high-performance computing technologies.
And I'm Johannes Licht, a PhD student with Torsten at ETH Zurich.
After the end of Dennard scaling and the slow death of Moore's law, the CMOS technology growth will soon come to an abrupt halt. This means that we now need to consider using these billions of transistors that we have on today's chips more efficiently, or to explore completely new technologies in the post-Moore computing era. One option to use these transistors more efficiently is to design domain-specific hardware. We've seen examples ranging from the Anton machine to recently developed deep neural network accelerators. Many of these projects have demonstrated up to 1 or even 2 orders of magnitude improvement in performance and energy consumption respectively. However, designing hardware is a complex and expensive task and is thus limited to a small set of important applications. Our tutorial aims to liberate programmers to use high-level languages to design their own high-performance hardware in a productive high-level language such as C++.
Our goal is that you will leave the tutorial with all the tools and the intuition that you need in order to be able to go and implement specialized hardware of your own. To achieve this, we interleave the presentation with live coding sessions where I show how the concepts that we cover are implemented in practice. The coding examples that we covered during the tutorial are online on GitHub already now, and we strongly encourage attendees to play with the code both before, during, and after the tutorial to get a feel for what it's like to work with high-level synthesis in practice. As an addition to this iteration of the tutorial, we're going to give you code for both Xilinx and Intel flavors of HLS to give you a feel for what the subtle differences are between the tools and to make sure you're ready to start coding HLS no matter which vendor you end up going with.